Hey everybody, welcome to Functional Programming. I'll be your host. By the end of this lesson, I hope that you too will be able to explain the tenets of functional programming. First though, let's figure out what they are. So I'm going to put, 3 minutes on the clock. I want you to just wrangle up as many different tenets of functional programming as you can. We don't need to go too deep on what they are yet. We're going to do that next. But first, let's just figure out what some of these tenets are. So 3 minutes. Adding it to my clock. All right, help me build a list. Go. Another minute. And that's time. So, Mr. Higger, please give me one of the tenets of functional programming.
Immutability.
Immutability. Love it. Christine, give me another one.
Disciplined state.
Yeah. Matt, give me another.
Pure functions and no side effects or discipline states.
Pure functions. Part of pure function is no side effect, which is kind of part of discipline state. Very nice. Todd, give me another. Unmute.
Referential transparency.
My favorite one. JT, give me another.
Reusability through higher orders.
Yep.
Yeah.
Reusability
Through higher order functions. Yes.
through higher order functions. Very nice. John, did you have any more that you found?
Type systems.
Okay.
And I think so. One of my questions is, like, I found here are the core principles, and I think I see a list of 6. Is that like a thing, like these 6 core principles?
No, it's not. It is an OOP. OOP has 3 or 4 pillars depending on who you ask, but they're the same 3 or 4 regardless. FP is not that way, which is one of the reasons why this is why we're making a list. Christine, did you find any more?
Is first class functions different from
Yeah.
higher order?
That is different than higher order. First class functions. Cool. Matt, did you find any more?
No.
Cool. This is a pretty good list. So let's do this. Let's work this backwards. John, I want you to research first class functions. Christine, I'd like you to research type systems. Matt, I'd like you to research higher order functions. Todd, I'd like you to research referential transparency. JT, I'd like you to research pure functions, and we'll talk about these other 2 together. But I'm going to put another 6 minutes on the clock. I want you to read about your topic, and then you're going to present about it to the rest of the group. 6 minutes. Go.
Oh, I was not muted.
Oh, crashed it. I was wondering when that was going to happen. Another 3 minutes. Another 30 seconds. All right. So, John, go ahead and get us started. What was your topic? Unmute.
First class functions.
Okay. What is a first class function?
So a first class function is when you treat a function like a first class object. A first class object is an object that allows you to, it basically allows you to treat it like the way that I would think about it, like any sort of variable in Ruby, where you can put it inside of a function. You could call a function using it as an argument. And then there's like, maybe that's not the best way to phrase it. But yeah, you can, so like in JavaScript, for example, you can put a function inside of a function. You could call a function without necessarily invoking it. So you could store it like a variable. You can use it as the argument to a function. I should have had the definition pulled up in front of me, but I was.
No, that's good. So that's exactly what it is.
Okay.
So with a function, we can pass things into functions, right? We can pass in booleans, we can pass in strings, we can pass in objects, we can pass in arrays, and we can pass in functions. A function isn't any different than any of those. That's what it means to be a first class object. So we actually can't do that with Ruby in quite the same way. You can't pass a method definition like around. You can't store that in another variable and then pass that variable to another method. That's not really how it works. Closest thing that we have to that in Ruby is a thing called procs, which you may have read about in some of the labs. But the ability to just use a function, store it in a value, pass it around, return it from things, that's a first-class function. Cool. Christine, what was your topic?
I had type systems.
Okay, tell me about type systems. What is a type system?
So I can't like quite grasp the concept of it, but it basically has to do with how a language is compiled. And so based on a language's type system, it'll enforce like a set of rules or like check data types and things like that to, I guess, indicate errors at compile and make it more efficient in that way.
Yep, that's pretty good. So if I have a sum function in JavaScript, let's get to a terminal. So if I have a sum function, takes in two numbers, and returns adding them together. So we'd expect to use that like that, right? And that'll work just fine. We can run this in the command line, and oops, it probably helps if I use the function keyword. Cool, so I can run this on the command line, and if I output that code, cool, I see my 4. Works just fine, right? But I can also pass a string into that if I want. And, it concatenates them together. Unusual, all right. What if I try to add false to fart? Weird. Coerce false into a string? What if I pass it an empty object? Object fart. We'll do the same thing if I do arrays. Yep. Weird. So it didn't stop me at all from trying to do that, right? Now, if I said something like that, now, at the time it tries to compile the code, if something other than a number is being passed into that function in those two arguments, it's not even going to try to run it. It'll go, nope, this was only designed to work with numbers. So now imagine you could have something like adding a positive number or positive integer. What if that were a type? There are certain assumptions that we can make on how we would work with those that are different than if it takes in literally anything. And we can find all those errors at the time that we're compiling the app, not while we're running the app, which is pretty cool. That's a type system. JavaScript really doesn't have one. TypeScript is an example of a type system, like kind of bolted onto JavaScript. Ruby has a type system. It's not quite as good as some other languages. And then if you look at like pure functional languages like Haskell or something like that, you get into pretty robust type systems. where you could do things like positive integers is a type. Cool.
You can't define your own type in JavaScript that easily.
Right. So the closest thing we have to that are classes in JavaScript. So you can see if something came from, has something in its prototype chain, but that's as good as we can get.
An argument like that?
What was that?
Can you check for the class type in that function argument?
No. So the way you do that is, so those types are like not a thing, but we could say something like if number one
So when you do type of, that actually gives you the class?
No, that gives you the raw type. So if it's a more complicated type, like something that came from a class, then it's always going to be object. So you can use instance of instead for that. So there would be something like that.
Okay. Interesting.
And that's all TypeScript is doing under the hood, is stuff like that. Cool. Let's see, our next one. Matt, what was your topic?
I had higher order functions.
Hoffs. Love it. What else? Or sorry, tell me about Hoffs.
It's a function that does at least one of the following. Takes one or more functions as arguments, and or returns a function as a result. And it is used for something called currying, which is a technique that transforms a function with multiple parameters into like a sequence of functions with each one having one argument.
Love it. So our Hoffs take in a function as an argument or return a function, or what was the other thing it could be?
It's used for something called currying.
Before that. So the definition of a higher order function is either takes in a function as an argument or it returns a function as a value, or what?
It was either takes one or more functions as arguments, returns a function as a result, and...
Or both.
Yeah, or both.
Yep. So that's the definition of one. And what did you say it was used for?
Currying.
It's a beautiful word. And what else did you find out?
That higher order functions are it's a concept where functions operate with other functions. Okay, that's pretty much what I described. Yeah.
So what are some examples in JavaScript of like where we do this all the time?
Event listeners.
Yeah, that takes in a function as an argument, right? It's the second argument to add event listener. First one is the type of event we're responding to as a string. Second argument is a function. Okay, very nice. What else? Where else in JavaScript do we use this?
Okay.
Yeah, like with your with for each or something like that.
Yeah, with our enumerables, for each, map, filter, find, reduce, all that kind of stuff. Those take in functions as arguments. So like this one, we could do it inline. We've done that a bunch of times. We can also make that a standalone function, and it works the exact same way. And then that would end up being like that. So those are the same thing. And they're taking in a function as an argument. Now, here's a thing that we've never really talked about before. Let's say map didn't exist. What is it doing? Say I had to make my own implementation of map. And map is going to take in an array, and it's going to take in, actually I'm going to do this backwards. It's going to take in the function to apply, and then some array. So we're looking for something kind of like map, double, and then 1, 2, 3. How would I make that work?
So it's creating a loop inside, storing each result and applying the function to each object in the enumerable and storing the result and returning the array of the results.
Beautiful, very well put. So yeah, what if I do something like new array is that, and then I do like some dirty fucking for loop after it. So I say I is less than some array dot length, increment I, and then for everything in this, I want new value is some array at I, but we'll say so that's the current element, and then we could say let current result equal function to apply, and we pass in current element, and then we take new array and push current result into it, and then return new array. I wonder if that works. So if I console log this, oops, someone didn't like. Map of undefined. So we're calling that. Let's see, does it work? There we go. There's our doubled numbers. We implemented map out of nowhere. So that's all these things are doing. They take in functions as arguments, like here, and then we can call them with stuff. That's a higher order function. Questions about that? All right. Thank you, Matt. And then let's see, Todd. What was your topic?
I had referential.
Sorry, I didn't mean to interrupt, but
Yeah.
do you think you can explain what currying is?
Sure.
Or is that not?
Oh, I'd love. Oh, goodness gracious me, I'd love to. So currying. Matt said that. Matt, what was your definition of currying again?
It's a technique to transform a function with multiple parameters in a sequence of functions with each function having a single argument.
Cool. So hey, this map function, this takes in multiple arguments, right? So currying is a way to transform that into something that only takes a series of functions that take one argument each. So what if what map actually does is it only takes in that function to apply. And what it returns, what do I call that? Sum array. It returns a function that takes in some array, Summer. Hey!
I think summary really, really fancy.
So that has transformed a function that takes in has multiple parameters into a sequence of functions that each take in one. And the way that we'd use that, instead of doing it like that, we'd do it like this. Let's slow that
When do you
down.
want to use that?
What was that?
And why? When do you want to use that and why?
In functional programming, every chance you get. But if I break this into some steps, I could say double an array equals map double, and then my doubled array equals double an array with 1, 2, 3 passed in. So that first one, this line 22, that gives us a function that doubles any array you pass in. And then we can call that here. We can also do all of those in one step by saying, and that is called currying. It's named after Haskell Curry, the mathematician.
Is that where the Haskell language comes from?
Correct. Yeah, it's some dude's name. And so John's question is, why, oh, why would we want to do such a thing? So for one, this is one of the ways that we get complex behavior out of simple behavior. So doubling an array, having a function that does that, we built that out of map, which just takes in any function to map over, and this double function here, and we can combine those into a brand new function. That's powerful. It allows us to make those Lego pieces super duper small and then combine them in increasingly complex ways. That's reason number one. From a math standpoint, the reason that it's real nice to have things only take in one argument is, so f of x equals mx plus b, okay? So like we can chart out different x's on a graph pretty easily. So that's our x's, that's our y. If we pass in a 1, then that's going to be here. And if we pass in a 2, that's going to be here. And if we pass in a 3, that's going to be here. And so we get some kind of predictable pattern on this. If instead this takes in x and y, this gets a lot trickier to chart and predict and run calculations with. Now, if we can get the best of both worlds by splitting those up, now I can predict the output given any input. And just as importantly, I can keep track of what the result of any given input is. The more variables, or the more parameters that something has, the more complex that gets exponentially. Cool. Let's see. Todd had referential transparency. Todd, what does referential transparency mean? It's my favorite one.
So that's a concept that works closely with pure functions and immutability. Mm-hmm. Your program has fewer assignment statements whose value doesn't change. You eliminate side effects with the technique. Basically, it says it's expressions in a program may be replaced by its value without changing the result of the program.
Ooh, love that. So we got fewer assignments and swap an expression for the result of that expression. So this is an almost obvious sounding kind of thing that is one of the most powerful things that we can do in JavaScript. So what this is saying, let's pull all this out. This. Okay, so this is an expression right here. This is saying that and an array with 2, 4, and 6 are identical. They are the exact same thing. It doesn't matter if you write one or the other. So what that lets us do is if we just had this array of 2, 4, and 6, like we could filter that so that we only get things that are like greater than 3, for example. Okay, that means that we can also do that with this expression since they're the exact same thing. So I could do dot filter number is greater than 3. Just like I could do these two expressions are identical. They mean the exact same thing. So anything we can do with the result, we can also do with the expression that generates that result. That's why we can chain one enumerable after another, after another, after another, because of referential transparency. An expression is the exact same thing as what it evaluates to.
The referential transparency is less of a practice and more of a property of like the languages that you could do functional programming on.
Correct. That's actually the case with most of these.
Yeah,
So like, go ahead.
It's like Scala makes it clear the moment you declare a variable. What's that mean?
So in a lot of functional languages, I don't know if this is the case with Scala. So we're taking advantage of referential transparency in this one. We could also do that as something like we can make all these like little placeholder variables. So I could break that into like 3 different steps also. And in some languages you have to, because they don't have referential transparency. In a functional language, this will get you lit on fire. This is what's meant by like fewer assignments. So you can usually do something kind of like this in a functional language, but it makes you feel it. They make you jump through some hoops to do things like declare variables, because they'd much rather you just do them as expressions like that.
So what's an example of a language that you can't do that?
What was that?
What's an example of a language without referential transparency?
Language that doesn't have referential transparency. I don't think Java does. I would be sort of surprised if C or C++ do. Most stuff that's kind of closer to the metal, I think, generally doesn't have referential transparency.
Closer to the metal, you mean like more base level?
Yep.
That's a cool phrase.
Yep. Cool. So, instead of this like highly Ruby styled thing, although I think Ruby has referential transparency. Don't quote me on that, but I think they do. But you generally see Ruby code kind of written more like this. And you generally see JavaScript code written more like this. And even better than that, this is where it starts feeling super functional, is we have that double function and then one of these kind of functions, and then we use those like that. That's starting to get mighty functional. It's not all the way there. I'll show you what this would look like all the way functional at the end of the lesson, but that's starting to get a little bit more to what we want our functional code to look like. Cool. JT, what was your topic?
Mine was pure function.
All right. What's a pure function?
So first, the function given the same inputs always return the same output.
Good. Was there a vocab word that was associated with that? That might be really hard to pronounce.
Oh, I don't know.
Okay. Same input gives the same output. The technical term for that is idempotent.
Oh, I didn't see that one.
Idempotent is same input, same output. Cool. Keep going.
Yeah, the second would be no side effect.
Yep. No side effects. What's a side effect?
It's like you're affecting other code or like other scope.
Yeah, other code, other scope. So anytime that we've done something like, pull this out. If I ever do something like let count equals 0, and then I make a function called increment that increments count, that's a side effect. Because increment doesn't own count. It's not inside of its scope. It's outside of its scope. And so if I'm modifying that, it's not a pure function anymore. Another part of pure functions, this is sort of related to same input, same output, is you have to rely purely on the things that you're being passed. So if this was instead increment by, and I do let increment amount equal 2, I say count plus equals increment amount. That's also not pure because I have to read that increment amount variable in from outside of the function instead of passing it in.
You could make it pure by passing in the count and the increment amount.
You got it. So if I do that, now that's a pure function. JT, anything else you found out about pure functions?
Not really.
Okay, cool. It's a good place to start.
In general, with like functional programming, the goal is to like reduce the amount of, like I think one of the things I was reading, and I just want to make sure I have this interpretation right, you're reducing the amount of not locally scoped variables in functions.
Mm-hmm. That's what discipline state is.
And you still can have some, but like, what are the are there guidelines on when you can use like, okay, here's a global variable for the project or something like that?
Basically, don't do that. But there's some ways you can get around having global variables. One is that it's kind of common to pass around containers. So there's an offshoot of Rails called Phoenix that I'm kind of vaguely interested in. Let me show you what their controllers look like. So in a Rails controller, you have stuff like params, and it's just magically there. in a Phoenix action in a controller, that explicitly gets passed in. And so you have direct access to that. And then even like rendering something, that comes in through this connection object that's getting passed around. So things that would otherwise be global, you just end up passing around in like big objects or hashes like that. That's one way to solve that.
Is there a performance hit to that?
Opposite, actually. By passing it in, it operates on it directly instead of having to look it up.
So how does this relate to the concept of like, I was reading about like destructive programming actually can be more computer exhaustive. And like, I'm wondering if this kind of relates to that. So like I guess what you showed in your function when it was calling nothing, that was actually a destructive method, because if you're saying like, change the count by 1, you're changing something that's outside of that thing's scope, as opposed to if you just returned a count that was like 1 higher than the one before. So is that actually faster?
Yes.
And is that part of the ideology? Okay.
So, like, this is kind of related to that. There's a difference between deleting something on your computer and formatting something on your computer. So let's say in my hard drive, I've got all these different spaces, little chunks. And each one of them has different little collections of whatever the hell on it. And then up here, we have like a table of contents. And I go, all right, I want Kyle.txt. And they go, cool. Kyle.txt is this one. I go, cool, I want Todd.txt. Todd's a little bit longer. Todd's is these two. When you delete something on your computer, the thing that actually happens, and this is the reason it always goes so fast, is it just deletes that pointer from the table of contents to where the data is. The data doesn't actually get deleted. That takes too long. This is also why, like, oh, but I hit empty recycle bin, but they were still able to get it off of my hard drive. It's because the ones and zeros didn't change at all. There's just no pointer to it anymore. Versus, oh, I want to format this. I want to zero it out so that instead that part of the hard drive is just zeros all the way across. That takes a long time. But that's the difference between deleting something and formatting something.
So formatting is the more rigorous. I'm
correct.
Making these zeros. So how does that tie into the destructive and non-destructive, which is, in other words, I guess destructive is formatting it.
Correct. If I'm just deleting some pointer from the table of contents, I can do that really quickly because it didn't actually change any of the data. I'm just not pointing to it anymore. And since I'm not pointing to it anymore, this is going to stay 0, 1, 1, 1, 1, 1, 1, 1 until like I need to write something and it goes, cool, what's the next place I can write some space? It's like, we haven't been pointing to this one for a while. Go ahead and use that. And so it ends up recycling it.
These places, are these in your RAM or your hard drive?
Porque no los dos, but your hard drive.
Okay. I don't know what porque los dos means.
It means why not both?
A little bit. Oh, okay.
But no, this is more referring to your hard drive than your RAM. There's similar ideas in both, though. Okay, very nice. Jason, good to see ya. Jeremiah Tab, be still my heart. So we didn't get to immutability. Old Jer Bear, can you tell me what immutability is? There's Jeremiah like actually working. All right, I don't see his camera or his mic. So immutability is once you assign something, you can't change it. So in other words, your variables are not variables anymore. And from a math standpoint, this makes a ton of sense. Let's go back to that y equals mx plus b thing. So if I write that as f of x equals 3x plus 2. All right, fair enough. If I pass 2 into that, I get 6, 8. So we'll say f of 2 equals 8. I can't later down the line say f of 3, f of 2 is now 25. That wouldn't make any fucking sense. You already said that f of 2 is 8. You're making a statement of fact, not making like a temporary placeholder where I'm just keeping track of this value for a little bit. And it's like a bucket, and I can pour it out and put something else in if I want. So in functional programming, our variable assignments are statements of fact. And so we can't change facts after we've declared them. So we rely on immutability. And once that's the case, a lot of other things get easier. Once we have a variable and we can't change it anymore, there's an entire class of problems that it's impossible to have now. So that's real nice. And then last one was disciplined state. Somebody help me out. Help me figure out what disciplined state refers to.
Like no global variables,
Yep.
kind of thing. Yeah.
So no globals, and to the extent that like you may have variables that aren't like precisely in the scope you're operating, we'll say like smallest scope possible.
Does that go to like the containers you were talking about?
Yes.
So can you give me an example of like how I would store something in like, let's say the calculator problem, right? Like,
Okay.
let's say I have a screen and I want ultimately like that's like one of the main things that all these functions that I'm writing are designed to change.
Yep.
So how would you go about handling something like that with functional programming that you want the smallest scope possible?
So that's a really good question. One of the solutions to that is to pass your screen around all over the place. All these things need the screen. Cool. That means the screen is a dependency for that function. Therefore, the function should always be passed the screen.
Yeah. I see what you're saying.
And then another functional attitude towards that is, and this doesn't play terribly nice with how the DOM works, but rather than like use that like set text or the .text content to change like what it should be, that's a very stateful way to handle that. And so that doesn't play too terribly nice with FP. The functional approach to that would be to, all right, I have whatever the screen is right now. I'm going to pass that around. And at the end of this chain of transformations, I'm going to get a new screen. And then I'm going to replace the existing screen with the new one that I generated.
Okay. All right. That makes sense.
All right, so let's review. We talked about first-class functions. We talked about type systems. We talked about higher-order functions. We talked about referential transparency. we talked about functional purity, we talked about immutability, and we talked about discipline state. These are some heavy fucking words, man. This is probably like the headiest, weirdest shit that we do in the program. And this is like first step of a long journey kind of a thing. But hopefully this gives you at least a little bit of a place to start. So ask me some questions about any of the things that we've talked about.
So why would a company like Apple be super OOP and not use like functional stuff? Because like Objective-C and Swift are object-oriented, right?
Correct. So in the battle between the functional folks and the OO folks, we got OO over here, we got FP over here. The OO side is very literary. The functional side is very mathematical. So in the literary side, we use metaphors that really closely relate to the problem that we're working on. So we say that a dog class can make dog objects. The dogs have behaviors like eat, and they take in a variable called food and whatever else. So that's kind of the OO approach to this. And one of the nice things about that is that A, very human friendly, and B, as our understanding of a problem changes over time, a small change in the problem space results in a small change in the programming space because we're using the same metaphor for both of them. With the mathematical approach, we're trying to find the underlying abstract relationship. And so that can change, a small change in our understanding of the problem domain, that can be a wildly different mathematic relationship. And so that ends up thrashing a lot more. So Apple is all about like human friendly and metaphor and like all that kind of stuff. And so that's one reason they like OOP. The other reason that a lot of people like FP, or OOP, I mean, is that change in understanding of your problem domain. We want to ideally have those changes stay small. There's other ways we can solve that problem in FP, but that's just an honest difference between the two.
So when you're conceptualizing, like, say something like a node backend, which, like, so far the way that we've kind of conceptualized backends is that we have these tables, and each table in Ruby is tied to like a class or something like that, and then that class has methods you can perform on it, and that's how you sort of build these relationships with that and how it interacts with the server or whatever. So and I haven't. This is, you could maybe forgive me if it's just something that you said in a video that I haven't seen yet.
I will never forgive you.
Is the concept in like Node, you're not like, are you kind of still treating each of these tables and tying them to like the equivalent of like a JavaScript object, which I know is technically functional programming, but it's done in a way that makes it look like an object and interpreted that way?
So for the back end, we're trying to figure out what the data transformation is. I start with an HTTP request, and I need to end with an HTTP response. And so everything in between those two is the transformation. Sometimes this approach to think of it is called black box thinking. If I give you this HTTP request, you give me this HTTP response. Black box. I don't know how you did it. I don't give a shit how you did it. And at a high enough level, this is how APIs work. As a client, I don't care what programming language you're using. I don't care what your database structure is. If I issue you a request that I formatted the right way, you give me this response. So if everything in between is the transformation, all right, what do I need to do? Well, I need to turn the request into like some kind of raw data. And so that might be the database request. I go, cool, so the request came in. I need to figure, shit, hang on. Where is it? Shut up. All right. So I need to get that data, and then I need to format that data, like serialize it, something like that. And then I need to stringify that. So I need to like turn it into JSON. And then I need to build the actual response string and then send that off. So it's a chain of data transformations. So I'm relying less on like my metaphors, like, I have a model which represents this, which represents this. And it's more like I take this parameter in and I poop this thing out, and the next thing takes that as its input and poops out a different thing, and we're just doing that one chain after another. And we can actually make those fairly complicated. You could have this start off two different things that end up recombining down the road. There's like, we can make that as complicated as it needs to be, but it's still viewed as like one chain of transformations that's happening instead of our like model view controller metaphor.
Right. Okay. Interesting.
It is. More questions about any of the stuff that we've talked about?
I just found some YouTube lecture series called Object-Oriented Programming is Embarrassing.
So yeah, even in like your initial research, you probably got the sense that this is a little bit of a holy war, and you'd be right. It is. It's been going on an awful long time too. This is approximately like a 70-year war or so.
What side are you on?
I'm like pretty heavily on the FP side.
You used to be over.
As my wife would like to remind everyone, I used to be pretty middle ground on the OOP side. Now I'm probably a little past middle ground on the FP side. So like you change over time, but
It's like FP is taking over now.
oh yeah, it's currently way hot. And some of that is that OO was so popular for like 20 years. And it got popular because it was starting to get just too awkward to do things functionally. And so OO was rediscovered. James Gosling made Java, which really sort of shot it into the stratosphere. And there was this whole software craftsmanship movement that was happening in kind of the early and mid 90s that piggybacked on top of the OO thing. And so all the original Agile Manifesto people, all of them are like old school OOP folk. And what we ended up with from all of that was a ton of just intellectual detritus that was getting in the way of making good software. People got way too into just applying stupid OO patterns without thinking. The programs got really bloated. There's certain problems that just got very difficult to solve with objects. And so about 5 years ago, we saw this rediscovery of functional programming. And so probably leading the charge on that, React, honestly. Angular took a very OO approach to front-end frameworks, as did Ember to some extent. And React was like, nah, fuck that. What if we stripped away all the OO stuff and approached this component-based architecture thing more functionally? And so they did, and that got a lot of people super interested in functional programming. And even like all of those other front-end frameworks, all of them were like, oh shit, you are super right about how much more efficient some of the FP stuff is. So a lot of them went FP under the hood because it was just so much faster. And it's going to swing back again. There's really valuable things from both sides of them. We do benefit from a literary perspective on our human problems. Also, we benefit from a mathematical perspective on them. And so they both have something to offer. And one of my favorite things about JavaScript is you can seamlessly just jump back and forth between both paradigms. Can't do that in Ruby. Ruby, like anything that even feels vaguely functional, is painful. Same thing with Python. For as much as like Python is billed as like the data language, I find like data transformations to be excruciating in Python because it doesn't have a lot of the like FP niceties. So yeah, there you go.
Wouldn't you argue that depending on what you're doing, there's an echo. The functional programming would be more useful in certain scenarios, whereas OO would be more useful in other scenarios?
Absolutely. If you can conceive of something easily as a data transformation, FP is probably the better tool to reach for. For example, at my last job, I worked on a calendar app. And so what this thing did was it combined, it was a training app for doctors and like scheduling training for doctors and that kind of stuff. So you'd have doctor availability, you'd have their equipment availability, you'd have trainer availability, you'd have room availability. And so you would paint these onto a calendar and then you go, I want to run this training on Tuesday. Who can do that? Or I need to train Dr. Streff. So when is Dr. Streff available? And so you are taking all of these different availabilities and doing some like subtractive math to figure out what you have left. That's a data transformation. And so I did that functional as hell. You could also have done that OOP style, but it's way, and that's what it originally was when I got there. And there were bugs that nobody could quite find because tracking down a bug in stateful OOP code is a nightmare. Way easier to do that with FP. So that was like a clear-cut, like, duh shit winner. Meanwhile, doing things like client-side state management. So this is what, like, in React they use Redux for. Vue has Vuex. I think the functional approach to that is elegant, but in practice, kind of weak shit. And you end up writing really repetitive code versus Ember, which went a very OO approach to client-side state management, where you have a model class and you have adapter classes and you have serializer classes. And I feel like their approach to that is very OO, but way more appropriate for that particular problem. Cool. What else?
Is there like, so is the concept of object-oriented programming really only big in like web development, or is that something that transfers into other tech fields as well?
Huge. Way bigger than web. In fact, you could make the argument that like web barely has any place in like the OOP conversation. But desktop software, games, all that stuff. And a lot of that stuff, especially like games, is a good example of that. OOP is not going anywhere. Like making a game functionally sounds like a nightmare to me. I would never do it.
Yeah, thinking about that, it'd be awful.
Yeah. Way easier.
You have so many variables. So many variables.
Yeah. So like let's say I got a platformer. Having like, okay, I have an instance of the zombie class, and that instance has this many hit points, and it's waiting on this timer to perform this move. All that stuff, keeping all that together, way easy. I like that. The functional approach to that would be like, separate from all of that, we're tracking the state of the application. There are two things of type zombie out, and their things are this. The behaviors of those zombies, how they walk, all that sort of stuff is kept completely separate from all of that. So it's like an OOP, we're combining state and behavior. The zombies' hit points and the zombies' like attack move are like all kind of defined in the same place. In FP, we're trying to separate those as much as possible. So how many hit points a zombie has and what a move is, like, those are totally separate things. Which is awkward. Way less prone to errors, though. It's got that going for it. Cool. What else? So our goal was to be able to explain some tenets of functional programming. Talk about first-class functions. They're just variables, just like Boolean, strings, anything else. Talk about type systems and how we can use those to ensure correctness in our programs. Higher order function either takes in a function or returns a function or both. Referential transparency, an expression and the result of the expression are identical. So if you can do something on one of them, you can do something on the other. Pure function, same input, same output. Doesn't have any side effects, doesn't rely on any outside state. Immutability, once you've assigned something, it doesn't change. If you need a different version of that, you need to make a copy of it. And then discipline state, no globals, keep your scope as small as possible. If you would like to write up your understanding of the tenets of functional programming and Slack it over to me, I will be happy to confirm or correct as needed. Elsewise, thanks everybody.
Thanks, Kyle.
Thank you.
Thanks, Tom.
Yep, yep.